Okay, so fill in the formula. Get the antiderivative right. That 1/3 is going to hang around until you have your 2 and your -1 plugged in. So 2 plus 2 cubed over 3 is 8/3 minus -1 minus 1/3. Okay, does that sound reasonable? All right, so let's see, 1/3 of 2, I'm going to go ahead and change these negatives to positive. All right, because I'm basically, remember, I'm distributing that negative. All right, so 2 plus 1 is 3, and 8/3 plus 1/3 is 9/3, which is another 3. So what's 1/3 of 6? 2. Okay. So here's what this means. Okay. Your average value, we're going to say, all right, remember this right here is representative of what? What is that? The area, which is also the integral, right? -1 to 2 of 1 plus x squared dx. Okay? Right? Now, that 2 right here tells us that we have a rectangle of height 2. This is 1, this is 2, assumably. This rectangle on the same interval has the same area as this interval. The blue rectangle, remember the height equals 2. That's right here. Has the same area as the interval. So the area under the curve. Okay? You got to keep the boundaries the same, the -1 to 2. And then that's what that says. Why is it important? I don't know. I guess average, I don't know what. Oh, wait. Average is a thing. Okay. Honestly, they don't really, you know how calculus like to switch words up? They usually don't. If it's average, they ask for average. They don't really switch it up. Okay? So, it's not real hard. It's just a matter of not getting the formula mixed up. Okay, so you have to have a formula memorized. All right, let's do a little extension of that. Okay, this is the mean value theorem for integrals. We had the mean value theorem for derivatives a long time ago. Okay. Again, f is assumed to be continuous on this interval. Okay. And there's some number c such that in this -1 to 2 area where we have that height of 2. You see it? I'm guessing just by my figure, I have a height of 2 here and a height of 2 here. So again, this is your average value right here. We already did that. It's 2. Okay. That's supposed to equal f of c. F of x, remember, is 1 plus x squared, wasn't it? What's f of c then? F of x is 1 plus x squared, so what's f of c? Right. Then we're going to solve 1 plus c squared equals 2. Okay, and hopefully we're going to find this number and this number, because that's what it looks like on the thing. All right, c squared equals, and c equals, good job, remember the plus or minus. There's the -1, there's the +1. These aren't always going to come out perfectly nice like that, but you can tell by looking at them on the graph. Okay, so the C just tells you where does that height show up. Okay, all right, any questions? Pretty basic, really. Okay, at what value C on the interval -1 to 1 does g of x equals e to the 2x satisfy the mean value theorem for integration? Okay, what is the mean value theorem again? What is the mean value theorem? The previous slide. F of C plus the C equals interval A to B of f of x dx. Okay, so anytime we talk about the mean value theorem, then you have to remember that formula. All right. Okay, now we put in our A and our B. What's my A? B is 1, B is 1. So I'm going to do, I'm just going to work down here, and then I'll work over here. 1 minus a -1. -1 to 1. F of x is e to the 2x. Okay? All right. I don't really expect you to know what e to the 2x looks like exactly, so we can do that here in a minute. Just kind of make a visual with it. What's 1 minus a -1? 2. All right. Okay. Go ahead and integrate that without your calculator. We're involved in the last one. Anybody cold? What are y'all doing? Are you using U? Good. Good work. And using substitution for intervals. I got the antiderivative yet? Remember how to do it? Like the substitution in general? No, what do you think it is?
The whole answer, like, yeah. E to the second minus e to the -2.
Okay, hold on. What's the antiderivative?
E to the 2x squared.
Okay, so what's u going to be here? 2x. So what's du dx? 2. So du equals 2 dx. So 1/2. Du equals dx. Okay. This has been replaced with 1/2 du. Didn't give myself much room, did I?
Wait.
Should be what?
1/2 times 1/2.
Yeah, I'm not doing that yet. I'm still working on the EU substitution here, okay? So 1/2, what's left in my interval? E to the u, what are my limits changed to? -2 and +4. Remember, this is u of 2. Here's u of 2, and u of 0. Okay? EU. All right, so now I'm ready. I got my 1/2 already. What's the antiderivative of e to the u? E to the u, and I'm now stuck with -2 and 4. Okay? That was anybody? Yeah. Top original. The what? If you change this to U, you have to take these. 2 times 2 is 4, is it not? Oh, yikes. Okay, there you go. Now you're making sense. Okay. I'm not. All right. So let's try that again. Thank you, Molly. Oh my gosh. My eraser is monstrous. So 2, is that better? I don't know. What I'm doing. So what should it be? Yeah. U of -1 is -2, right? And U of 1 is 2. So now we got it right. Okay. All right. So it's my, I already did my integration. I need to like work it out. So I got 1/4 here, right? All right. 1/4 e to the 4. Oh, yikes. We forgot to change this back. I say we, but it's really me. All right. 2 to -2. Okay. 2 minus e to the -2. And I'm okay with that. All right, so we've done one side of the mean value theorem. Don't forget we got to do the other side, get matched up here. So what's f of c? It's f of c. Remember f of x or g of x. So what's f of x? F of c? E to the 2c. Okay. So now we get to solve this. Wow, that looks exciting, especially when we don't have a number. So we're going to get we're going to solve with our calculator. We did the integration by hand. Okay, let's solve with our calculator because I don't think we have anything. All right. So how am I going to do this solving with my calculator? What am I going to do? With e to the 2c, but really I have to use x, right? Okay, e to the 2x. Okay, and then 25 parentheses e squared. Oh wow, what am I doing? Hit the right button here. Butler, okay. Minus e to the -2. Okay. Oops. All right. So how do I get the, what do I do now? Wrap it. There's e to the 2x. Another thing, remember, is a constant. All right, so now what? Intersect. Okay. Second graph. Number 5, intersection. There's only one, so I can hit the enter button 3 times.
Why did we do the du dx thing? Because I didn't like. I understand the process of it, but I don't understand why.
Well, because otherwise you're not going to get the 1/2 if you take the derivative of e to the u. Anytime the derivative of e to the u is e to u. If you figure out anything else than a single variable, you need to use your substitution because it's more complex. It's a composite function.
Okay, so if it was just e to the x, you could have just like pulled it.
Yes, just like we did here. Okay, so what's my intersection? C equals, which number is it equal to? X, right, because we're solving for x. 0.297. Good. Now, there's not any, or 298 going around. Let's do 297. Okay, There's not any way you could have found that on your own. Okay? So that's the mean value theorem from start to finish. Not here's this, then here's this, put them together. Okay? Any questions on that? So what does that mean? Let's see. Let's go here. All right. We are interested in -1 to 1. Okay? So this area is the same as, where's my 2.2? Probably about right. That's 1.2 is about right there. Okay? So my height is about right there. This has about the same area as the black. It was probably a little taller with it. Okay? Because of my fat pencil. The C is the X. The C is right here. That's where we'll give you, let me get that a little better. That will give you the height of the rectangle that has the same area as your original. Right. Or it's the average value of all the f of x's, if that's all you want. But the c's not really involved in the average value. Okay? Anything else? All right. Okay, this is a little bit different, but it's used manipulation. Okay, assume that h of x is a continuous function, okay, over the interval -4 to 5. All right. H of x is continuous. So those are my two criteria. You gotta have a closed interval and be continuous. A and B are fixed real numbers such that -4 is less than A, which is less than B, which is less than 5. So basically, A and B are in between -4 and 5, and A is less than B. That's all it takes. Okay, the following definite interval statements are true. Okay, so we got from -4 to B of h of x is -22. We got from A to 5 of h of x is 13, and 5 to -4 of h of x is 10. Okay, so how do I find, formula-wise, how do you find the average value of h of x over -4 to 5? Average value equals 1 over, so 5 minus the -4, integral of -4 to 5 of h of x. Okay, so this is what we want to know. And they only gave us that kind of information. So let's see if you can figure it out. From -4 to B, some random number B, and then we went from -4 to 5. That last interval is pretty close, isn't it? So this is 1/9, right? 1/9. Okay, what's this? -10. So that is -10/9. Okay? Just deals with what information they gave us. Remember the interval rules, we had to switch those around. If we want it to be the same as this, that negates that number. Okay? So this tells us that this equals -10. Okay? All right.
Wait, about
Average value. Yeah, that's why we ended up making it -10 as opposed to 5. Okay? All right, calculate the average value on -4 to B. weird because you don't know B. You're not supposed to be finding B. You're just supposed to be manipulating the interval. No. Just pause it. Is it just what's buzzing?
That's 22.
Well, you have 22, negative 22, or you have this, negative B minus 4. All right, it's pretty, like it's weird, but it's very straightforward when you actually just know the formula. Okay, so average value equals 1 over B minus a negative 4, right? Just B plus 4. Times the integral from negative 4 to B of h of x. This is what? Okay. So 1 over B plus 4 times negative 22 is 22 over B plus 4. You don't want the name. One note. Okay, well that makes sense why then you were confused. I'm finished. So, so you can work on your H problem. Can you what? There. I got 2 books, but yeah, you can leave them on the desk. I am freezing, but I might put my extra new. Anybody pork in here? Yeah, new shirts. That's what we need, another shirt. Kentucky blue. Pork. Yeah, it's cute. I just don't like this Kentucky blue. I bought some Ricola cough drops the other day. I thought it was going to gag when I put them in. These are not Ricola. Yeah. Ricola. Same idea. You knew what I was talking about, right? All right, let me see if I have some. This was not. This was lemon, eucalyptic, or gross. Yeah, but cherry or too sweet. Sarah, I lied. I don't have. Wait, let me look. One more box. I do have one, but let me just say they're sugar-free. Think, and they sometimes give you gas. Sugar-free.
The cough drop gives you gas?
Anytime you have anything that's sugar-free, they have that product tea, that olefin or something that they put instead of, yeah. Well, you're swallowing it bit by bit. No. Yep.
Yeah, mine's working.
Did you all buy the PDF? I'm just hacking.
Angel's. I got a hardback, and then they sent me the link to this one. But the book was like $200.
I know. Any math books are terrible. A lot of editors have to go through it. Make sure it's not little errors.
I use my phone.
Yeah, I get that. So you bought the book? Okay, but you're okay. Just you're not supposed to buy you're not supposed to use the PDF if you did buy a book. It's kind of a ethical thing.
I'm really cold now. Sorry, I didn't do like. I just put like.
Okay. I was cold earlier, so I'm going to catch up.
I also sit right along the.
Oh my gosh, I sit right in the air in our Spanish class. And Profe always has the AC like cranked. And I'm sitting there and I'm like shivering, like I don't want to say anything.
And your hair is wet every morning.
Yeah, I take showers in the morning.
No, that's a problem.
No, I mean not always, sometimes.
So that makes you a little colder. I took a shower at 6:10 this morning. He got to school at 7:15.
I can't more shower. I'm really scared.
Yeah. I can't wake up if I don't shower in the morning.
I just look like if I don't shower at night, by the end of the next school day, it looks like I haven't showered in like 2 days.
Miss Grace, any my catch? Wait, I can use this. I got it. You're good. Doing my hands, right, ladies? The intervals. Nasty. One over 4 months. Allie. What?
I do everything wrong.
You do everything what?
Wrong.
Oh, I don't believe that. Simple math. There's nothing simple about algebra.
Is the antiderivative of sine negative cosine?
Okay, for number 8, you put 4 out to the front, or you have to be the sign you?
Because it ends up not being a 4, it ends up being a 1-4. Because you have to, and remember to change your limits.
I'm really drunk over
Oh,
Chapter 5.
It will come back to me.
Okay, I know it will. That's why I wanted to start coming back earlier than later.
Oh, that's something else.
Whatever's else out there on the operating side.
Yes, because I literally had to change the video. I was like, I was like a month. It was like my emotions coming out. Yeah. That's what it is. How do you do 2?
How far did you get?
Well, I got 1/4 pi. And then 0.
Where'd you get the 1/4? Your limits are pi and negative pi, aren't they?
Yeah, but then you have to change the limits for you, right?
Okay. So what are your new limits?
4 pi and negative.
Okay, what's that size?
Big pi, like pi, or it's like 2 pi. Then you're gonna multiply.
Did you do the substitution where you pulled the 4 around? Because u equals 4x, right?
Yeah.
So du,
That's 1/4 du equals dx.
okay, so you got a 1/4, and you already have a 1/2 pi.
So I got 1/8 pi.
Okay.
So then my limits are still 4 pi.
So what's the sign of 4 pi?
1.
Okay.
Oh, it's negative 1. Because it's negative percent.
I took the negative out with the 1/8 pi just because I don't like messing with it. Too many negatives going on.
Okay.
It should have worked out the
And then
same.
minus a
So the sign of negative 4 pi is the same thing. So you're going to have 1 minus 1 inside there, right?
Really?
Yeah.
So I have negative 1 minus 1.
What's that 4 pi? It's not negative 1.
Well, it's negative.
No, I took my negative out
Oh, yeah.
with my negative 1/8 pi.
I'm sorry. Yeah, that's where, I guess that's where I just got it. Plug in my computer.
Would that be negative 4? This is 4 pi is still here. So that's what's 4, negative 4 pi is the same place.
What was negative 4 pi place?
Both sides? Because you're going to go around once, twice.
Oh.
I was thinking you go like 1, 2, and then you go back. I don't know why. I don't know. Okay. 1 minus 9.
It's time for lunch, I guess. Yes, it is. Have a good lunch, ladies. Why is it sad? Are you serious? No, I'm serious. I'm still peeking. Oh, for gosh. Oopsie.